Good morning. Hi, I'm Lisa Cohen, Executive Director of the Washington Global Health Alliance and a board member for Life Science Washington. I'm here today with the chair of the board, the phenomenal chair of the Life Science Washington board, and a friend and colleague of mine, John Wecker. John's also the president and CEO of Pacific Northwest Diabetes Research Institute. So John, tell me what's going on at PNDRI these days. What are you excited about?
Well, you know what, I want to take this opportunity to give you a little bit of history of our institute, because very few people actually understand and know about the phenomenal history. So we are the oldest independent biomedical research institute here in Seattle. We were founded in 1956 by a name that you'll find familiar. His name was Dr. William Hutchinson.
Yes.
And he went on to eventually found the Fred Hutchinson Cancer Research Center. And it was founded when Bill took the cancer research that was being done at the Pacific Northwest Research Institute, which we were known back then as, he took the cancer research and he spun out and he created the Fred Hutchinson Cancer Research Center. So we like to think that we were the first Hutch, even though we're very happy to be eclipsed by our offspring.
Yes.
So we have a phenomenal history, and Bill was a really visionary guy. He had a wonderful quote that I use quite often. Bill was convinced, and remember, this is back in the 1950s, so it's fairly revolutionary for the time, that biomedical research had the ability to correct man's infirmities, which I think is a great vision for the possibility that we're beginning to really realize today.
Yeah.
And we heard this phenomenal talk from Lee Hood this morning about personalized medicine and the revolution that's coming there. And I think that Bill would have found that to be right along the same lines in which he was thinking. So after Bill died in the late 1990s, the staff that came on board, the faculty that was recruited, were all diabetologists. They were all experts in diabetes. So we took a small turn into focusing on diabetes.
Why was that at the time?
It was more driven by the president at that time, Paul Robertson. He was a world-renowned diabetologist, phenomenal researcher, and he just brought in faculty that he enjoyed working with, and so over time it evolved in that direction. But that said, and you know, Lisa, from your work in global health, diabetes is a huge medical problem around the world. So it made sense to be able to focus on a disease with such a profound impact around the world. But the reality is that diabetes today is treated exactly as it was 95 years ago when we discovered insulin. And while there's been really huge improvements in improving the quality of life of patients through humanized insulin and glucose monitoring and indwelling pumps, the reality is that we haven't made that much significant progress. And unfortunately, it makes me sad to say that true breakthroughs in potential cures and really being able to prevent diabetes, especially type 1 diabetes, still really isn't on the horizon. Now that said, I think one of the major advances we've made in diabetes, and in many other diseases as well, is to understand that there's a predisposition to disease of all varieties that we carry within our genome. But at the same time, the expression of that predisposition really is an interaction between the environments, something that happens in the environment coupled with what our genetic predisposition is. And we've been studying this phenomenon in diabetes for over 10 years now. We have a longitudinal study following a whole cohort of children from around the world who have a genetic predisposition to type 1 diabetes. For 10 years, we've been following these children and taking the kinds of blood samples and urine samples and saliva samples that Lee Hood was talking about. We're intimately, taking diaries of when they're exposed to new allergens, and all in the hope of someday finding some clues as to what is that gene-environment interaction that leads to disease. And so looking forward to that day, more recently we've said, you know what, we need to be prepared. If we can find those cues, how can we capitalize on them? How do we turn that into new ways to prevent or to treat or to diagnose? And so more recently we've been investing in bringing on some of the best and brightest geneticists in the world, together with computational scientists, all in the hopes of cracking that understanding of how do those genes and environmental interactions lead to disease, with a hope that we can again prevent and perhaps change the course of disease progression. So we've been, of course, diabetes is not the only disease that has this gene environmental interaction. So our scientists work on diseases such as liver cancer, neurodegenerative disorders, congenital abnormalities, and of course diabetes and metabolic disorders, because all of these share that common thread of something between the genetic predisposition and the environmental risk that leads to the disease. So again, if we can crack that and really understand that, hopefully we'll be able to both significantly address the diabetes epidemic, but as well many other diseases around the world.
So I want to talk about diabetes just for a second more, because as you mentioned, the global burden for diabetes is huge.
Yeah.
But we're also talking about type 1 and type 2.
Right.
So would you talk about how you're addressing those differently as you think about this?
That's a good question. We're focusing primarily on type 1 at the moment, and that environmental, well, I actually should say that environmental gene interaction is common to both type 1 and type 2 diabetes. So fundamentally, as we get down to that very basic level of genetics, gene environmental interaction, hopefully the insights that we uncover will be able to apply to both type 1 and type 2 diabetes. But again, as I said, the majority of our work right now is focusing on that type 1 diabetes.
Yep, to do that. And so, and as you choose, tell me how PNDRI chooses, or how the scientists choose what else they want to study.
Okay, that's a really good question. And in some ways, it makes us look somewhat opportunistic, and yet what we need to find for our scientists to really help crack that understanding is they need to have diseases for which we can reasonably understand what that genetic predisposition is. We need typically large databases of information that our computational scientists can mine in order to gain those insights. And of course, our scientists, by their nature, want to do something to improve people's health. So they tend to choose and seek out diseases of significant magnitude: liver cancer, neurodegenerative disorders, diabetes. So when you put all that together, when those things come together, those are the things they gravitate to, knowing that if we can gain insight by looking into liver cancer or insight into looking into neurodegenerative disorders, those insights are likely to translate just as well into diabetes and some of the other diseases that, again, have that gene-environment interaction component.
And as we recognize more and more, it's just critical for organizations like PNDRI to collaborate and to partner with other organizations, sort of fill in the gaps and buttress what our scientists are working on. Yeah. Can you talk about how you seek out partners, people who might be here at the conference?
Sure. So as I've described, we do some very basic genetic research. And my scientists will be the first one to say, boy, we can answer a lot of questions, but when it comes to a specific disease, we don't always know whether we're asking the right question. So we need to partner with experts in the disease themselves, and usually people who have access to these large data sets or clinical samples, because those are the kinds of directions and input we need in order to be able to know that we're asking the right question and hopefully getting the right answer. So we seek out partners at the University of Washington, for example, Washington State University. We're looking into some of the for-profit companies now. Fred Hutchinson Cancer Research Center, all institutes and organizations that, again, have this unique access to clinical samples, to data sets, to insights into diseases that will partner and complement the fundamental genetic knowledge of our scientists.
So what are the biggest challenges for you as a president and CEO of this organization? Funding. Okay, always funding.
Always funding. It's an interesting, I was going to say dance, and I guess I'll just use that word, to let the scientists be scientists, to let their individual scientific curiosity and passion lead them to where they want to go, but at the same time making sure that it's got some direction that will ultimately lead to the possibility of a translational activity or a practical outcome. So it's a balance that I walk constantly, both in terms of what we encourage them to do, what we incentivize them, what we reward them to do, but at the same time recognizing that I can't predict where their curiosity might lead them to some amazing breakthroughs. So I don't want to, at the same time, tamper or step on that or challenge. So it's an interesting, again, it's a kind of a dance.
Right.
And I think they appreciate the flexibility, but also do appreciate that opportunity to say, you're right, that's really important. That's where we need to keep our attention on.